Okay, well, I'm back. Hopefully everything is going well. This lesson will be related to pages 130, 131, 132, and 133 in your book. The assignment, which you should have in your class syllabus, asks you to solve inequalities on page to solve absolute value problems. The inequalities should already be done by now, hopefully, based on the last video. So you'll be solving absolute value problems, page 133, numbers 7 through 47, and the odd ones. Certainly if you want to do the even ones also, that's your decision. But everything and all the information that you will need to solve those problems you can find on pages 130 and 131, as well as 132. So the key concept here is absolute value, which is really a very basic concept when we talk about the number line and we think of 0. The distance from 0 to any number on the number line is its absolute value. Seems simple enough, and it really is simple if you just understand one key concept, that the direction you go in on the number line does not affect the distance. So, in plain English, if you have the number 5, which is 5 places to the right of 0 on the number line, its absolute value is 5. If you have the number -5 on the number line, obviously going in the negative direction from 0, its value is also, its absolute value is also 5. So if you have your book, this would be good. I'm just going to read the definition and give you a couple of examples. So on page 130, at the top, number 1, the heading is Solve Equations Involving Absolute Value. So just to read it to you, recall that on the real number line, the absolute value of A equals the distance from the origin to the point whose coordinate is A. For example, there are 2 points whose distance from the origin is 5 units, -5 and +5. So the equation x with the absolute value symbol equals 5 will have the solution set of -5 and 5. So again, all that really means when you start to solve these problems is understand that it's really about the distance from 0, and the negative really gets taken out of the equation. So we're going to cut to some examples that I will have on my whiteboard marker, and these examples will not be specific to the problems in your book, and then we'll cut to another video with some going after the specific examples in your book. So we'll see you in a bit. Okay, to get you started, we are going to use the examples in the book. Specifically, page 130. Example 1. A and B. Okay? Hopefully you can see that over my shoulder. Solve the equation. A is written as the absolute value of x plus 4 equals 13. So the first thing we want to ask ourselves, are we in a position to solve for absolute value? And because the absolute value is isolated without any other variables to deal with right now, we're in good shape to start. So we want to rewrite this as, without the absolute value signs, as x plus 4 equals 13. And we will now solve for x plus 4 equals 13 by subtracting 4 from both sides of the equation, resulting in x equals 9. Simple enough. So we have x equals 9 for starters. Now we also have to remind ourselves that there are two locations on the number line that the absolute value of 13 is the same, positive and negative. So we will rewrite this equation again as x plus 4 equals minus 13. And if you look in the book, they do lay this out pretty much identical to the way I'm laying it out. So we will, again, to isolate x, subtract 4 from both sides of the equation, resulting in x equals minus 17. So we have two numbers that are part of our solution set, and that is minus 17 and 9. So that would be your answer. For example, 1, letter A on page 130. So let's move on to the second example on page 130, which is slightly different. And it is written as the absolute value of 2x minus 3 plus 2 equals 7. So this is slightly different than A, in that the absolute value is not isolated on one side of the equation. So very simply, we have to do something with that positive 2. And since we're wicked good at algebra, we are going to subtract 2 from both sides of the equation, resulting in, and we'll save a step and we'll get rid of the absolute value symbol now. We have 2x minus 3 equals 5. Now, we'll also have to solve for 2x minus 3 equals negative 5, because the absolute value of 5 and the absolute value of minus 5 is both 5. So let's start with the first one, adding 3 to both sides of the equation. We have 2x equals 8, dividing both sides by 2. We end up with x equals 4. So that is one of our solutions. So we'll just put it up here as a reminder. And then we will solve for 2x minus 3 equals minus 5. Excuse me. Adding 3 to both sides of the equation. We obviously those cancel. We end up with 2x equals a minus 2. Dividing both sides by 2 so that we can end up with x equals a negative 1. So our solution set is minus 1 and 4. See you in a little while. We'll be back for more. Cut. Okay, we are back again with a slightly different example for solving absolute value problems. One of the key factors is to isolate your absolute value to one side of the equation without any other variables to deal with. So in the previous example, we had a number that we needed to subtract or add from. In this example, we have a similar situation with that number. We also have a number, in this case 5, that needs to be multiplied. So these are the steps I would take. I would start by adding 3 to both sides of the equation. That would result in 5 times the absolute value of x plus 3 equals 10. Okay, well, we still have one more issue here, and that's that 5. So how do we get rid of something that we needed to multiply something else by? Well, very simply, if we divide both sides by 5, we then end up with the absolute value of x plus 3 equals 2. Rewritten, x plus 3 equals 2. We will also need to solve for x plus 3 equals a minus 2, because the absolute value is, as we've said probably too many times by now, that it's based on the distance from 0 on the number line. See if I can keep hitting that tripod. It's starting to upset me. Probably upset you too. So let's start with x plus 3 equals 2. Very simply, we will subtract 3 from both sides of the equation, ending up with x equals minus 1. Now we need to solve for x plus 3 equals a minus 2 instead of a plus 2. Again, same procedure. We will subtract a minus 3 or negative 3 from both sides of the equation. Those will cancel. The result is x equals minus 5. So our solution set, or our possible solution set, would be minus 5 and minus 1. Now, what I failed to mention, but I made an assumption, and I just don't want to assume anything at this point, is that you would want to plug minus 5 back into your original equation to see if it worked, and then you would want to plug minus 1 back into your original equation to see if it worked. You're certainly quite capable of doing that. In this case, I will tell you that both of these work, so your solution set is minus 5 and minus 1. Okay, number 7 on your homework, page 133, asks you to solve the following. The absolute value of 2x equals 6. So at this point you should be comfortable with the process. We will rewrite this as 2x equals 6, getting rid of the absolute value signs. In this case, we will divide both sides by 2, ending with x equals 3. That's one of our solutions. Now, in this case, the other answer ends up to be a minus 3, but do not make the mistake of just automatically assuming that you would just turn that into a negative 3. That would be a huge mistake. What you want to do is rewrite this and resolve for the absolute value of 2x equals minus 6. So we would write 2x equals minus 6, dividing both sides by 2, we would end up with x equals minus 3. Our solution set would be minus 3 and 3. When you plug them back in, it works. Okay? Now let's do number 9. Number 9 reads, the absolute value of 2x plus 3 equals 5. 2x plus 3 equals 5. We will rewrite this without the absolute value signs. 2x plus 3 equals 5. We will solve for x, starting with subtracting 3 from both sides of the equation, resulting in 2x equals 2. Dividing both sides of the equation by 2. Result, x equals 1. So we have x equals 1. We will then rewrite the equation because it is an absolute value equation. We would like to solve now for 2x plus 3 equals minus 5. Subtracting 3 from both sides of the equation, we end up with 2x equals a negative 8. Dividing both sides by 2, we end up with x equals minus 4. So our solution set is minus 4 and 1. And, excuse me, and as I mentioned in number 7, if you had simply taken that first solution, x equals 1, and assumed that the other variable, the other part of the solution would be minus 1, obviously that would have been a huge mistake. So that is number 1. The absolute value of 1 minus 4t, don't be intimidated by the letter, it's just the letter. Could be x, y, or z, it's just 4t plus 8 equals 13. So we will start by subtracting 8 from both sides. The purpose of this is to isolate the absolute value, and we end up with the absolute value of 1 minus 4t equals positive 5. Rewriting that, we will have 1 minus 4t equals 5. Subtract 1 from both sides, and we end up with a minus 4t equals 4. We can then divide by a minus 4 so that we end up with t equals minus 1. So that would be one of our options, one part of our solution set. That's for number 11. We want to rewrite the equation. Actually, let's just take it from the top here. It's good practice. The mistake that some people might make at this point would be to solve for a minus 13, because that would, you're assuming that's the negative direction of absolute value. But that would be a mistake. We have to isolate the absolute value of 1 minus 4t. So what we will do, just as we did in the first part of the equation, we'll subtract 8 from both sides, ending up with the absolute value of 1 minus 4t. Cancel those 8s, equals 5, which we've already solved for, but now we want to solve that for minus 5. That's where we get the number the number line going in the opposite direction, not minus 13. So we can rewrite that as 1 minus 4t equals a minus 5. Subtracting 1 from both sides of the equation, minus 4t equals minus 6. We want to come up with, we want it to read t equals, so we would divide that side by negative 4. Also divide that side by negative 4, so we would end up with t equals minus 6 over minus 4. Of course, a negative divided by a negative would be a positive, and we would reduce 6 over 4 to 3 over 2. So our solution set will read minus 1 and 3 over 2 for number 11.